Question 1. Performance analysis shows that a critical customer-facing application hosted on Oracle Cloud Infrastructure, OSI, is experiencing high response times, particularly during peak usage periods. The primary bottleneck has been identified as slow retrieval of frequently accessed data from the database. As an OCI developer, you need to propose a solution to improve application performance while ensuring data remains compliant with regional data residency requirements. Which of the following approaches best addresses this challenge? Option A. Migrate the entire application and its database to a different cloud provider that is perceived to have better database performance. Option B. Implement a distributed caching layer using OCI's managed caching services to store frequently accessed data closer to the application instances. Option C. Develop a custom in-memory data grid solution from scratch to cache database query results. Option D. Increase the size of the database compute instances and add more read replicas without optimizing data access patterns. Correct answer is B. Implement a distributed caching layer using OCI's managed caching services to store frequently accessed data closer to the application instances. Explanation. Scenario analysis. This scenario presents a common challenge for Oracle Cloud Infrastructure, OSI developers. Optimizing application performance and cost-effectiveness without compromising security or compliance. The core difficulty lies in balancing the immediate need for improved response times with the long-term implications of architectural choices, particularly concerning data residency and access controls, which are critical under OCI's shared responsibility model and general cloud governance principles. Developers must make informed decisions that align with business objectives, technical feasibility, and regulatory adherence. Correct approach analysis. The correct approach involves a thorough understanding of OCI services and their implications for data handling and performance. Leveraging OCI's built-in caching mechanisms, such as Oracle Coherence or OCI Caching Service, directly addresses the performance bottleneck by reducing latency for frequently accessed data. This approach is best professional practice because it is a targeted solution that directly mitigates the identified performance issue. Furthermore, it aligns with OCI's architectural best practices for high-performance applications. By keeping data within the same OCI region or availability domain where the application resides, it minimizes network hops and adheres to data residency considerations, which are often dictated by regulatory frameworks that require data to remain within specific geographic boundaries. This proactive approach ensures compliance and enhances user experience without introducing unnecessary complexity or security risks. Incorrect approaches analysis. One incorrect approach involves migrating the entire application to a different cloud provider without a comprehensive evaluation of OCI's capabilities. This is professionally unacceptable because it bypasses a direct opportunity to optimize within the existing OCI environment, potentially incurring significant migration costs and introducing new, unaddressed performance or compliance challenges in the new environment. It also fails to leverage the investment already made in OCI expertise and infrastructure. Another incorrect approach is to implement a custom, complex caching layer without utilizing OCI's managed services. This is professionally unsound because it increases development and maintenance overhead, introduces potential points of failure, and may not be as secure or performant as OCI's native solutions. It also risks creating a solution that is not easily scalable or integrated with other OCI services, potentially leading to future technical debt and compliance issues if not meticulously managed. A third incorrect approach is to simply increase the compute instance size without addressing the underlying data access latency. While this might offer a temporary performance boost, it is an inefficient and costly solution. It does not solve the root cause of the performance degradation, which is the time taken to retrieve data. This approach is professionally deficient, as it represents a brute force method that fails to apply intelligent architectural design and can lead to unnecessary operational expenses, a key consideration in cloud, cost management, and governance. Professional reasoning. Professionals should employ a structured decision-making framework when faced with performance optimization challenges in OCI. This framework typically involves 1. Problem identification and scoping. Clearly define the performance bottleneck and its impact. 2. Solution exploration. Research and evaluate OCI native services and architectural patterns that address the identified problem. Consider performance, cost, security, and compliance implications. 3. Proof of concept POC. If necessary, conduct small-scale tests to validate the effectiveness of potential solutions. 4. Implementation and monitoring. Deploy the chosen solution and establish robust monitoring to track performance, cost, and adherence to requirements. 5. Iteration and refinement. Continuously review performance data and adjust the solution as needed. This systematic approach ensures that decisions are data-driven, aligned with best practices, and compliant with relevant regulations, leading to sustainable and effective solutions. Question 2. Operational review demonstrates that a development team is provisioning multiple compute instances in Oracle Cloud Infrastructure to support a new microservice. To expedite the deployment process and allow for immediate testing and iteration, the team is considering granting these compute instances broad administrative privileges within the OCI tenancy. What is the most appropriate decision-making approach to ensure security and compliance? Option A. Grant the compute instances broad administrative privileges to simplify management and accelerate development, relying on network security groups to control external access. Option B. Configure the compute instances with read-only access to all OCI resources to prevent accidental modifications, accepting that some necessary write operations might be blocked. Option C. Bypass IAM policies for these development instances and solely rely on network security to isolate them, assuming they are not handling sensitive production data. Option D. Implement granular identity and access management, EAM, policies that grant each compute instance only the specific permissions required for its intended function, adhering to the principle of least privilege. Correct answer is D. Implement granular identity and access management, EAM, policies that grant each compute instance only the specific permissions required for its intended function, adhering to the principle of least privilege. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid development cycles and the need for robust security and compliance within Oracle Cloud Infrastructure, OCI. Developers are tasked with delivering features quickly, but this must be balanced against adhering to OCI's security, best practices, and potential regulatory requirements that might govern data handling or application deployment, even if not explicitly stated in the prompt. The core of the challenge lies in making informed decisions about resource provisioning and configuration that are both efficient and secure, without introducing vulnerabilities or non-compliance. The correct approach represents best professional practice because it prioritizes a proactive and integrated security posture. By leveraging OCI's identity and access management, EAM, policies to enforce the principle of least privilege, developers ensure that compute instances only have the necessary permissions to perform their intended functions. This directly aligns with OCI's security model and is a fundamental tenet of secure cloud development. It minimizes the attack surface and reduces the risk of unauthorized access or data breaches. This approach is ethically sound as it demonstrates a commitment to protecting data and system integrity, and it is compliant with general cloud security best practices that are implicitly expected in a professional OCI development context. An incorrect approach that involves granting broad administrative privileges to compute instances is a significant regulatory and ethical failure. From a regulatory perspective, such broad access increases the likelihood of accidental or malicious misconfigurations that could lead to data exposure or service disruption, potentially violating data protection regulations if sensitive data is involved. Ethically, it demonstrates negligence in safeguarding resources and user data. Another incorrect approach, which is to bypass IAM policies entirely and rely solely on network-level security, is also problematic. While network security is important, it is not a substitute for granular access control. Relying only on network security creates a false sense of security and fails to address internal threats or compromised credentials, leading to potential regulatory noncompliance and ethical breaches related to due diligence in security. The professional reasoning framework for similar situations should involve a layered security approach. Developers should always start by understanding the specific OCI services being used and their security implications. They should then consult OCI's IAM documentation and security best practices to design granular policies. Before deploying any resource, A review of the proposed IAM policies and network configurations should be conducted. If there is any doubt about the security implications or compliance requirements, seeking guidance from OCI security specialists or compliance officers is paramount. This iterative process of design, review, and validation ensures that security and compliance are embedded throughout the development lifecycle, rather than being an afterthought. Question 3. Analysis of the potential impact of a new feature deployment on an existing Oracle Cloud Infrastructure application's availability and performance. What is the most effective and professionally responsible approach for an OCI developer to undertake? Option A. Rely on the development team's collective experience and past similar deployments to estimate the potential impact without extensive data collection. Option B. Postpone the detailed impact assessment until after the feature has been deployed to the production environment to observe real-time effects. Option C. Focus solely on the code changes for the new feature, assuming the underlying OCI infrastructure will automatically compensate for any performance degradations. Option D. Conduct a thorough review of OCI monitoring and logging data, alongside application-specific performance metrics, to identify potential resource contention, error spikes, and latency issues that might arise from the new feature. The correct answer is D. Conduct a thorough review of OCI monitoring and logging data, alongside application-specific performance metrics, to identify potential resource contention, error spikes, and latency issues that might arise from the new feature. Explanation. Scenario analysis. This scenario presents a common challenge for Oracle Cloud Infrastructure, OCI developers, assessing the impact of a proposed change on an existing application's availability and performance. The challenge lies in balancing the need for innovation and feature enhancement with the critical requirement of maintaining service continuity and user experience. Developers must consider not only the direct technical implications of the change, but also its ripple effects across interconnected services, data integrity, and security posture within the OCI environment. This requires a proactive and thorough approach to identify potential risks before they manifest as production issues. Correct approach analysis. The correct approach involves a systematic and comprehensive impact assessment that leverages OCI's native monitoring and logging tools, alongside application-specific metrics. This method represents best professional practice because it is data-driven and aligns with the principles of robust cloud governance and operational excellence. By analyzing logs from OCI services like OCI logging and OCI monitoring, developers can gain insights into current resource utilization, error rates, and performance bottlenecks. Correlating this with application-specific metrics provides a holistic view of how the proposed change might affect critical business functions. This proactive identification of potential issues allows for informed decision-making, risk mitigation strategies, and the development of effective rollback plans, thereby ensuring compliance with service-level agreements, SLAs, and maintaining customer trust. This aligns with the general principles of responsible cloud development and deployment, emphasizing reliability and resilience. Incorrect approaches analysis. An approach that relies solely on developer intuition or anecdotal evidence without empirical data is professionally unacceptable. This fails to acknowledge the complexity of cloud environments and the potential for unforeseen interactions between services. It represents an ethical failure by potentially exposing users to service disruptions and data loss without adequate due diligence. An approach that focuses only on the immediate code, changes and ignores the underlying OCI infrastructure, and its configurations is also professionally flawed. This overlooks the shared responsibility model in cloud computing and the potential for infrastructure-level impacts, such as resource contention or network latency, to affect application performance. This can lead to regulatory noncompliance if SLAs are breached due to inadequate infrastructure planning. An approach that delays the impact assessment until after the change has been deployed to production is a critical professional and ethical failure. This demonstrates a disregard for operational stability and user impact, potentially leading to significant business disruption, reputational damage, and financial losses. It is a direct violation of best practices for change management and risk mitigation in any IT environment, especially a cloud-based one. Professional reasoning. Professionals should adopt a structured approach to impact assessment. This begins with clearly defining the scope of the proposed change and identifying all affected OCI services and application components. Next, they should gather baseline performance and availability metrics using OCI's monitoring tools. Then, they should simulate or test the proposed change in a non-production environment, meticulously observing its impact on key performance indicators and error logs. Finally, they should document the findings, identify potential risks, and develop mitigation and rollback strategies before proceeding with any production deployment. This systematic process ensures that decisions are informed, risks are managed, and the integrity of the OCI environment and its applications are preserved. Question 4. The assessment process reveals that a new feature for an e-commerce application on Oracle Cloud Infrastructure, OCI, will involve processing and storing customer payment information. The development team is eager to deploy this feature quickly to capitalize on an upcoming sales event. Which of the following approaches best ensures compliance and security while enabling timely deployment? Option A. Conduct a comprehensive impact assessment to identify potential data privacy and security risks associated with handling payment information. Review OCI security best practices for sensitive data, and integrate necessary security controls and compliance checks into the development and testing phases before deployment. Option B. Focus solely on the functional requirements of the new feature, ensuring it processes payments correctly, and defer any security or compliance considerations to a later, unspecified review. Option C. Rely on OCI's default security configurations and assume that the platform's inherent security measures are sufficient to protect customer payment information without further application-specific analysis. Option D. Proceed with the feature development and deployment, and plan to address any security or compliance issues that arise after the feature is live in production. The correct answer is A. Conduct a comprehensive impact assessment to identify potential data privacy and security risks associated with handling payment information. Review OCI security best practices for sensitive data, and integrate necessary security controls and compliance checks into the development and testing phases before deployment. Explanation. Scenario analysis. This scenario presents a common challenge in cloud development, balancing the need for rapid innovation and feature deployment with the imperative to maintain robust security and compliance. Developers are often under pressure to deliver new functionalities, which can lead to overlooking or downplaying the potential security implications of their code. The professional challenge lies in integrating security and compliance considerations seamlessly into the development lifecycle, rather than treating them as an afterthought. This requires a proactive mindset and a deep understanding of the Oracle Cloud Infrastructure, OCI security model, and relevant compliance frameworks. Correct approach analysis. The correct approach involves proactively identifying and mitigating potential security risks early in the development cycle. This aligns with the principle of security by design and shift-left security practices, which are fundamental to modern cloud development and compliance. By conducting a thorough impact assessment that considers data sensitivity, access controls, and potential vulnerabilities in the context of OCI's shared responsibility model, developers can ensure that new features do not inadvertently expose sensitive data or create compliance gaps. This approach demonstrates a commitment to responsible development and adherence to best practices for protecting customer data and maintaining regulatory compliance within the OCI environment. Incorrect approach is analysis. One incorrect approach is to assume that OCI's built-in security features are sufficient without a specific assessment of the application's unique requirements. This overlooks the fact that OCI provides a secure foundation, but the responsibility for securing the data and applications running on it and ensuring compliance with specific regulations rests with the customer. Failing to assess the impact of new features on data handling and access controls can lead to regulatory violations, data breaches, and reputational damage. Another incorrect approach is to defer security and compliance reviews until after the feature has been deployed to production. This is a reactive and high-risk strategy. It significantly increases the likelihood of discovering critical vulnerabilities or compliance issues when they are most costly and damaging to remediate. This approach violates the principle of proactive risk management and can lead to significant business disruption and potential legal repercussions. A third incorrect approach is to focus solely on functional requirements without considering the security implications of the data being processed or stored. This can lead to the development of features that, while functionally sound, may inadvertently violate data privacy regulations, e.g., GDPR, CCPA, depending on the jurisdiction of operation or internal security policies. It demonstrates a lack of holistic understanding of the development process and its broader impact. Professional reasoning. Professionals should adopt a risk-based approach to development. This involves understanding the data lifecycle, identifying sensitive data, and assessing potential threats and vulnerabilities at each stage. When developing new features, a critical step is to perform an impact assessment that specifically considers how the new functionality will interact with data, access controls, and existing security measures within OCI. This assessment should inform the design and implementation of the feature, ensuring that security and compliance are integrated from the outset. Regular security training and awareness, coupled with a culture that prioritizes security, are essential for fostering responsible cloud development practices. Question 5. The assessment process reveals that a new microservice being developed for an OCI-based application will process customer personally identifiable information, PI, and potentially financial transaction details. The development team is eager to deploy quickly to meet market demands. Which of the following actions is the most critical to ensure compliance with relevant U.S. data protection regulations? Option A. Focus solely on the functional requirements of the microservice, deferring any security or compliance considerations to a separate, later phase of the project. Option B. Proceed with the microservice development and deployment, and address any potential compliance issues that arise after the application is live. Option C. Conduct a comprehensive data impact assessment to identify potential risks to PII and financial data security and privacy, and document mitigation strategies aligned with U.S. regulatory frameworks such as CCPA and PCI DSS. Option D. Rely on OCI's built-in security features and assume that the platform's compliance certifications automatically cover the application's specific data handling requirements. The correct answer is C. Conduct a comprehensive data impact assessment to identify potential risks to PII and financial data security and privacy, and document mitigation strategies aligned with U.S. regulatory frameworks such as CCPA and PCI DSS. Explanation. The assessment process reveals a common challenge in cloud development, balancing the need for rapid innovation with robust security and compliance. In the context of Oracle Cloud Infrastructure, OCI, and its adherence to U.S. regulatory frameworks, as implied by the exam's focus on U.S.-centric cloud development practices, developers must proactively consider the impact of their architectural decisions on data privacy and security. This scenario is professionally challenging because a seemingly minor change in data handling can have significant downstream compliance implications, potentially leading to breaches of regulations like HIPAA or PCI DSS, if sensitive data is mishandled. The correct approach emphasizes a proactive, risk-based methodology. By integrating security and compliance considerations early in the development lifecycle, developers can identify potential vulnerabilities and ensure adherence to relevant U.S. regulations. This aligns with the principle of security by design and privacy by design, which are fundamental to responsible cloud development under U.S. law. It demonstrates a commitment to due diligence and a thorough understanding of the regulatory landscape, minimizing the risk of non-compliance and associated penalties. An incorrect approach that overlooks the impact assessment for sensitive data processing would represent a failure to comply with data protection mandates. For instance, if the application handles protected health information (FI), failing to assess the impact on HIPAA compliance could lead to unauthorized disclosure, severe fines, and reputational damage. Similarly, if the application processes payment card information, neglecting the impact assessment concerning PCI DSS requirements could result in security vulnerabilities that expose cardholder data, leading to significant financial and legal repercussions. Another incorrect approach might involve assuming that OCI's inherent security features are sufficient without a specific assessment for the application's unique data flows and regulatory obligations. This is a failure of due diligence, as cloud provider security is a shared responsibility, and specific application-level controls and assessments are still required. Professionals should adopt a decision-making framework that prioritizes understanding the data being processed, its sensitivity, and the applicable U.S. regulatory requirements e.g., HIPAA, PCI DSS, CCPA. This involves conducting a thorough impact assessment that evaluates how architectural choices affect data security, privacy, and compliance. If potential risks are identified, mitigation strategies should be developed and implemented before deployment. Continuous monitoring and periodic reassessment are also crucial to adapt to evolving threats and regulatory changes. Question 6. Research into the secure migration of sensitive customer financial data to Oracle Cloud Infrastructure, OSI, reveals a need to implement robust data protection measures. A development team is tasked with designing a solution that ensures compliance with data privacy regulations while allowing authorized applications to process this data. Which of the following architectural approaches best addresses these requirements? Option A. Implementing network-level security controls using OCI Virtual Cloud Network, VCN, security lists to restrict access to the object storage bucket without implementing application-level encryption. Option B. Storing sensitive customer financial data in plain text within OCI object storage, relying solely on OCI identity and access management, EAM, policies to restrict access to authorized users and services. Option C. Encrypting data at rest using OCI Vault for key management, but transmitting the data between OCI services and to external applications without encryption. Option D. Encrypting data at rest using OCI Vault for key management, encrypting data in transit using TLS/SSL for all communications, and implementing fine-grained access control policies in OCI Identity and Access Management (EAM) for authorized personnel and services. The correct answer is D. Encrypting data at rest using OCI Vault for key management, encrypting data in transit using TLS/SSL for all communications, and implementing fine-grained access control policies in OCI Identity and Access Management, EAM, for authorized personnel and services. Explanation. Scenario analysis. This scenario presents a common challenge for Oracle Cloud Infrastructure, OSI developers, ensuring data privacy and compliance when migrating sensitive customer data to the cloud. The core difficulty lies in balancing the need for efficient data processing and accessibility with the strict requirements of data protection regulations. Developers must understand not only the technical capabilities of OCI services, but also the legal and ethical obligations surrounding data handling. Failure to do so can lead to severe penalties, reputational damage, and loss of customer trust. The challenge is amplified by the dynamic nature of cloud services and evolving regulatory landscapes, requiring continuous vigilance and adaptation. Correct approach analysis. The correct approach involves leveraging OCI's robust security features and adhering to a principle of least privilege. Specifically, encrypting data at rest using OCI Vault for key management and encrypting data in transit using TLS/SSL for all API calls and data transfers are fundamental best practices. Furthermore, implementing fine-grained access control policies within OCI Identity and Access Management, EAM, to restrict access to sensitive data only to authorized personnel and services is crucial. This approach aligns with the principle of data minimization and security by design, which are cornerstones of modern data protection regulations. By encrypting data and strictly controlling access, developers ensure that even in the event of a breach, the sensitive information remains protected and unauthorized access is prevented, thereby upholding legal and ethical obligations. Incorrect approaches analysis. Storing sensitive customer data in plain text within OCI object storage without any encryption, even if access is restricted via IAM policies, represents a significant regulatory and ethical failure. While IAM policies control who can access the data, they do not protect the data itself if the storage service is compromised or if an authorized user misuses their access. This violates the principle of confidentiality and integrity, as the data is exposed to unauthorized viewing or modification. Implementing encryption for data at rest, but failing to encrypt data in transit when transferring it between OCI services or to external applications is another failure. Data in transit is vulnerable to interception by malicious actors, compromising sensitive customer information. This neglects the requirement for secure communication channels, a fundamental aspect of data protection. relying solely on network-level security controls, such as OCI Virtual Cloud Network, VCN security lists, to protect sensitive data without implementing application-level encryption and strict access controls is insufficient. Network security is a perimeter defense. It does not protect data if an attacker bypasses the network or if an insider threat exists. This approach fails to provide defense in depth for sensitive data. Professional reasoning. Professionals should adopt a risk-based approach to data security. This involves identifying sensitive data, understanding the applicable regulatory requirements e.g., GDPR, CCPA, or relevant industry-specific regulations, and implementing layered security controls. The decision-making process should prioritize data protection by design and by default. This means embedding security and privacy considerations into every stage of the development lifecycle. When choosing OCI services, developers must evaluate their security features and ensure they align with compliance mandates. Regular security audits, vulnerability assessments, and continuous monitoring are essential to maintain a secure cloud environment. Understanding the shared responsibility model in OCI is also critical. While Oracle secures the cloud infrastructure, the customer is responsible for securing their data and applications within the cloud. Question 7. The audit findings indicate that security testing is not consistently integrated into the CI/CD pipeline for applications deployed on Oracle Cloud infrastructure, potentially leading to the introduction of vulnerabilities into production environments. Which of the following strategies best addresses this finding in accordance with OCI best practices for secure development? Option A. Assign all security testing responsibilities to a dedicated, separate security team that operates independently of the development teams. Option B. Implement automated security scanning tools, SAST, DAST, and integrate them directly into the CI/CD pipeline, alongside OCI native security services for secrets management and access control. Option C. Schedule comprehensive manual security reviews only after applications have been deployed to the production environment. Option D. Acknowledge the audit findings but maintain the current development workflow, assuming that existing ad hoc security checks are sufficient. The correct answer is B. Implement automated security scanning tools, SAST, DAST, and integrate them directly into the CI/CD pipeline, alongside OCI native security services for secrets management and access control. Explanation. Scenario analysis. This scenario presents a common challenge in cloud development, balancing the need for rapid iteration and feature deployment with robust security and compliance requirements. The audit findings highlight a potential gap in the development lifecycle where security testing is not consistently integrated, leading to risks of exposing sensitive data or non-compliance with Oracle Cloud infrastructure. OCI, best practices, and potentially relevant data protection regulations. Though specific regulations are not mandated for this exam, the principles of secure development are universal. The professional challenge lies in identifying the most effective and compliant method to address this gap without unduly hindering development velocity. Correct approach analysis. The correct approach involves integrating security testing directly into the CI/CD pipeline. This aligns with the principles of DevSecOps, which emphasizes shifting left security by embedding it early and continuously throughout the development lifecycle. For OCI developers, this means leveraging OCI's native security services and integrating them with CI/CD tools. For instance, using OCI Vault for secrets management, OCI Identity and Access Management (IAM) for granular access control, and incorporating automated security scanning tools e.g. Static Application Security Testing SAST, Dynamic Application Security Testing DAST, within the pipeline. This proactive approach ensures that vulnerabilities are identified and remediated before code reaches production, thereby reducing risk and maintaining compliance with OCI's security posture and general data protection principles. It represents best professional practice because it is efficient, scalable, and minimizes the likelihood of security breaches or compliance violations. Incorrect approaches analysis. One incorrect approach is to rely solely on post-deployment manual security reviews. This is a reactive measure that is often too late to prevent issues from reaching production. It is professionally unacceptable because it significantly increases the risk of data exposure and compliance failures, as vulnerabilities may have already been exploited. It also creates a bottleneck, slowing down the release cycle and increasing the cost of remediation. Another incorrect approach is to delegate all security responsibilities to a separate security team without involving developers in the process. This creates a disconnect and can lead to misunderstandings about security requirements and implementation details. It is professionally unacceptable because it fosters an us vs. them mentality and fails to instill a security-first culture within the development team. Developers are best positioned to understand the code and its potential vulnerabilities, and their active participation is crucial for effective security. A third incorrect approach is to ignore the audit findings and continue with the existing development process. This is a severe ethical and professional failure. It demonstrates a disregard for security best practices, compliance obligations, and the potential harm to users and the organization. This approach directly contravenes the principles of responsible cloud development and could lead to significant legal and reputational damage. Professional reasoning. Professionals should adopt a proactive and integrated approach to security. When faced with audit findings related to security gaps, the decision-making process should involve 1. Understanding the root cause of the identified issues. 2. Evaluating potential solutions against OCI best practices and general security principles. 3. Prioritizing solutions that offer continuous security integration throughout the development lifecycle. 4. Collaborating with security experts and development teams to implement and maintain effective security controls. 5. Regularly reviewing and updating security practices in response to evolving threats and OCI service updates. This systematic approach ensures that security is not an afterthought but an intrinsic part of the development process, leading to more secure, compliant, and reliable cloud applications. Question 8. Compliance review shows that a new application being developed on Oracle Cloud Infrastructure, OCI, will process sensitive customer data that must legally reside within the European Union. The development team is considering how to ensure this data residency requirement is met throughout the application's lifecycle. Which of the following approaches best ensures compliance with data residency regulations within the OCI environment? Option A. Focus solely on securing the application's API endpoints and network traffic, assuming that if the data is protected in transit and at rest, its physical location is less critical. Option B. Rely on the OCI support team to automatically identify and relocate any data that is inadvertently stored outside the European Union after the application is deployed. Option C. Configure all OCI resources, including databases and storage, to be deployed within an OCI region located in the European Union, and verify that data processing operations are also confined to this region. Option D. Implement robust application-level encryption for all sensitive data, and assume that OCI's global infrastructure will manage the data's location securely. Correct answer is C. Configure all OCI resources, including databases and storage, to be deployed within an OCI region located in the European Union, and verify that data processing operations are also confined to this region. Explanation. Scenario analysis. This scenario presents a professional challenge centered on data residency and compliance within Oracle Cloud Infrastructure, OCI. Developers are tasked with building applications that handle sensitive customer data, and a critical aspect of this is ensuring that data is stored and processed in compliance with relevant regulations. The challenge lies in balancing the flexibility and cost-effectiveness of cloud services with the strict legal and contractual obligations regarding data location. Misinterpreting or overlooking these requirements can lead to significant legal penalties, reputational damage, and loss of customer trust. The need for precise understanding of OCI's regional capabilities and data governance policies is paramount. Correct approach analysis. The correct approach involves leveraging OCI's region-specific services and policies to ensure data residency. This means understanding that OCI offers distinct regions, e.g., US East, UK South, APAC Southeast, and that data stored within a specific region remains within that geographical boundary, subject to the laws of that jurisdiction. For developers, this translates to explicitly configuring resources, such as object storage buckets or autonomous database instances, to reside in the designated region that meets the compliance requirements. This proactive configuration directly addresses the data residency mandate by ensuring data is physically located where it is legally permitted to be. This aligns with best professional practice, by prioritizing compliance and risk mitigation from the outset of the development lifecycle. Incorrect approach is analysis. One incorrect approach is to assume that all OCI services automatically adhere to data residency requirements without explicit configuration. This oversight fails to acknowledge that OCI services, by default, might utilize global infrastructure for performance or availability, which could inadvertently place data outside the required jurisdiction. This represents a regulatory failure as it violates data residency laws and a professional failure due to negligence. Another incorrect approach is to rely solely on application-level encryption without considering the physical location of the data. While encryption is a crucial security measure, it does not inherently solve data residency issues. Data encrypted and then stored in a non-compliant region still violates residency laws. This is a regulatory failure because the data's physical location is the primary concern for residency, not just its security state. A third incorrect approach is to delegate data residency responsibility entirely to the operations team after development is complete. While operations teams play a role in infrastructure management, the architectural design and resource provisioning decisions made during development are where data residency is fundamentally established. Shifting this responsibility post-development is a reactive measure that increases the risk of noncompliance and represents a failure in integrated compliance practices. Professional reasoning. Professionals should adopt a compliance by design mindset. This involves thoroughly understanding the data's sensitivity, the applicable regulatory frameworks, e.g., GDPR, CCPA, or specific industry regulations, and the capabilities of the cloud provider to meet those requirements. Before commencing development, developers should consult OCI documentation regarding regional services and data governance. During the design and implementation phases, they must actively select and configure OCI resources to align with data residency mandates. Regular reviews and audits, involving both development and operations teams, are essential to ensure ongoing compliance. This proactive, integrated approach minimizes risk and builds trust with stakeholders. Question 9. Which approach would be most appropriate for an Oracle Cloud Infrastructure developer tasked with storing sensitive customer personally identifiable information, PI, for an application, ensuring compliance with data privacy regulations and robust security? Option A. Store PII in plain text within OCI object storage, relying on application-level access controls for security. Option B. Implement a custom encryption solution for PII, managing encryption keys manually on developer workstations. Option C. Store PII in a publicly accessible OCI object storage bucket, relying on the application to filter access. Option D. Store PII in OCI object storage with server-side encryption enabled and enforce strict access policies using OCI Identity and Access Management (IAM), while considering data masking for non-production environments. The correct answer is A. Store PII in plain text within OCI object storage, relying on application-level access controls for security. Explanation. Scenario analysis. A common challenge for Oracle Cloud Infrastructure developers is managing sensitive data, such as customer personally identifiable information, PI, within cloud applications. Ensuring compliance with data privacy regulations is paramount. The scenario presents a situation where a developer needs to implement a data storage solution for PII, requiring careful consideration of security, access control, and regulatory adherence. The professional challenge lies in balancing the need for accessible data for application functionality with the strict requirements for protecting sensitive information, especially when dealing with potential cross-border data transfers or varying data residency requirements. Failure to implement appropriate controls can lead to significant legal penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach involves leveraging Oracle Cloud Infrastructure's native security and data management services to implement robust data protection. This includes using Oracle Cloud Infrastructure Identity and Access Management, OCIAM, to enforce the principle of least privilege, ensuring only authorized users and services can access the PII. Furthermore, employing OCI Vault for managing encryption keys and OCI object storage with server-side encryption, SSE, or client-side encryption, CSE, for storing the data provides a secure foundation. Implementing data masking or tokenization for non-production environments and for data that doesn't require direct PII visibility in application logs or analytics, is also a best practice. This approach aligns with general data protection principles and common regulatory frameworks that mandate data minimization, purpose limitation, and robust security measures for sensitive data. Incorrect approach is analysis. Storing PII in plain text within OCI object storage without any encryption or access controls is a severe regulatory and ethical failure. This directly violates data protection principle that requires safeguarding sensitive information from unauthorized access and disclosure. It exposes the organization to significant risks of data breaches and noncompliance with data privacy laws. Implementing a custom encryption solution without leveraging OCI's managed services, such as OCI Vault, introduces significant risks. Custom solutions are often more prone to implementation error, key management vulnerabilities, and may not be as rigorously audited or certified as native cloud services. This can lead to compliance issues if the custom solution does not meet the stringent security standards required by data protection regulations. Storing PII in a publicly accessible OCI object storage bucket, even if encrypted, is a critical security and regulatory failure. Public accessibility negates any security benefits of encryption by allowing anyone to attempt to access the data. This is a direct contravention of the fundamental principle of restricting access to sensitive data only to authorized entities. Professional reasoning. When dealing with sensitive data in OCI, developers must adopt a security-first mindset. The decision-making process should prioritize understanding the data's sensitivity, identifying relevant regulatory requirements, e.g., GDPR, CCPA, or other applicable data privacy laws, and then selecting OCI services that provide the necessary controls. This involves a thorough risk assessment, followed by the implementation of a layered security strategy that includes strong authentication, authorization, encryption, and auditing. Developers should always consult OCI documentation and best practices for data security and compliance. When in doubt, seeking guidance from security architects or legal counsel specializing in data privacy is a prudent step. Question 10. The review process indicates that a development team is integrating a third-party analytics service into an OCI application to process customer usage data. The third-party service is hosted in a different geographic region than the primary OCI tenancy, and the team has not explicitly verified the third party's compliance with U.S. data residency regulations for customer data. Which of the following actions is the most appropriate professional response to ensure compliance? Option A. Configure OCI network security groups to restrict outbound traffic to the third-party service, assuming this will mitigate any data residency risks. Option B. Immediately halt the integration and conduct a thorough due diligence assessment of the third-party service's data handling practices, security certification, and explicit adherence to U.S. data residency laws before proceeding. Option C. Proceed with the integration, assuming that OCI's inherent security features will protect the data, and address any compliance concerns if they arise post-deployment. Option D. Rely on the third party's general terms of service, which mention data security, as sufficient assurance that U.S. data residency regulations are being met. Correct answer is C. Proceed with the integration, assuming that OCI's inherent security features will protect the data and address any compliance concerns if they arise post-deployment. Explanation. The review process indicates a common challenge in cloud development, ensuring data privacy and compliance when integrating third-party services with Oracle Cloud Infrastructure. OCI. Developers must balance the need for functionality with the stringent requirements of data protection regulations. This scenario is professionally challenging because a misstep can lead to significant data breaches, regulatory penalties, and reputational damage. The core of the challenge lies in understanding the shared responsibility model in OCI and how it extends to data processed by integrated services. The correct approach involves a thorough understanding of OCI's data residency and security controls, coupled with a deep dive into the data handling practices of the third-party service. This means verifying that the third-party service can meet the specific data residency requirements mandated by the relevant jurisdiction, in this case, implicitly U.S. regulations given the exam context, and that its security posture aligns with OCI's best practices and applicable compliance frameworks. This approach represents best professional practice because it proactively addresses potential compliance gaps before they manifest as breaches or violation. It demonstrates due diligence, a cornerstone of responsible cloud development, ensuring that the integration does not inadvertently expose sensitive data to unauthorized access or processing outside of compliant boundaries. An incorrect approach would be to assume that because the data is being processed within OCI, it automatically adheres to all regulatory requirements, regardless of the third-party integration. This overlooks the critical aspect of data flow and processing by external entities. A failure to verify the third party's compliance with data residency laws, such as those governing the transfer and storage of personally identifiable information, PI, within the U.S., constitutes a significant regulatory failure. Another incorrect approach is to prioritize functionality over security and compliance, leading to the integration of a service without adequate security vetting or data handling assurances. This directly violates ethical obligations to protect user data and can result in severe penalties under regulations like the California Consumer Privacy Act, CCPA, or similar U.S. state-level privacy laws. Professionals should adopt a decision-making framework that begins with a clear understanding of the data sensitivity and the applicable regulatory landscape. Before integrating any third-party service, a comprehensive risk assessment should be conducted, focusing on data privacy, security, and compliance. This includes scrutinizing the third party's privacy policies, security certifications, and data processing agreements. If the third party cannot provide sufficient assurances, alternative solutions or mitigation strategies must be explored. The principle of privacy by design should guide all development decisions, ensuring that compliance is an integral part of the solution, not an afterthought. Question 11. The analysis reveals that a developer is implementing an OCI function service to process customer financial transaction data. The function requires access to an OCI object storage bucket containing transaction records and needs to write process summaries to another object storage bucket. Given the sensitive nature of financial data, which of the following approaches best ensures compliance with data protection principles and OCI security best practices for this serverless function? Option A. Implement strict IAM policies for the function's execution role, granting only read access to the source object storage bucket and write access to the destination bucket. Encrypt data in transit using TLS and ensure sensitive data is not logged. Option B. Rely on the default IAM policies provided by OCI for functions, assuming they offer adequate security for financial data processing. Option C. Configure the function's execution role with broad permission to manage all object storage resources within the tenancy and store transaction ID in the function logs for debugging. Option D. Store the raw transaction data directly within the function's ephemeral storage for processing, and then delete it after execution without any explicit encryption. The correct answer is C. Configure the function's execution role with broad permission to manage all object storage resources within the tenancy and store transaction ID in the function logs for debugging. Explanation. The analysis reveals a scenario where a developer is tasked with implementing a serverless function in Oracle Cloud Infrastructure, OCI, to process sensitive customer data. The challenge lies in ensuring that the function adheres to OCI's security best practices and relevant data privacy regulations, specifically within the context of the 1Z0-1084-20 exam's assumed jurisdiction, which for this exam is generally understood to align with U.S. federal and state regulations concerning data privacy and cloud security, without specific mention of other jurisdictions. The developer must balance the need for efficient data processing with robust security controls to prevent unauthorized access or breaches. The correct approach involves leveraging OCI's built-in security features and adhering to the principle of least privilege. This includes configuring the serverless function with appropriate IAM policies to grant only the necessary permissions for its operation, encrypting data both in transit and at rest using OCI's KMS service, and ensuring that any sensitive data is not logged in plain text. This aligns with general data protection principles and common regulatory requirements for handling sensitive information, emphasizing proactive security measures and data minimization. An incorrect approach would be to assume that OCI's default security settings are sufficient for processing sensitive data. This overlooks the responsibility of the developer to actively configure and secure resources. Another incorrect approach would be to store sensitive data in plain text within the function's logs or temporary storage, as this creates a significant vulnerability and violates data privacy, best practices, and potential regulatory mandates regarding data protection. Finally, granting overly broad permissions to the serverless function's execution role, beyond what is strictly required for its intended purpose, represents a failure to implement the principle of least privilege, increasing the attack surface and the potential impact of a compromise. Professionals should adopt a risk-based approach, starting with a thorough understanding of the data being processed and the applicable regulatory landscape. Before development, they should identify potential security threats and vulnerabilities. During development, they must prioritize security by design, utilizing OCI's security services and adhering to the principle of least privilege. Regular security reviews and testing are crucial to ensure ongoing compliance and protection. Question 12. Cost-benefit analysis shows that a cheaper, less secure object storage option for sensitive customer data in Oracle Cloud Infrastructure, OCI, is available, but a more secure, compliant option with enhanced auditing features comes at a higher monthly cost. Considering the potential for data breaches and the implicit need for responsible data handling in cloud environments, which approach best aligns with professional best practices for an OCI developer? Option A. Opt for the most expensive, feature-rich object storage service available to ensure maximum security, regardless of the actual data sensitivity. Option B. Select the more secure, compliant object storage option with enhanced auditing features, even at a higher monthly cost, to mitigate risks and ensure responsible data handling. Option C. Implement the cheaper object storage option, but add custom security measures to compensate for its inherent weaknesses. Option D. Choose the cheaper, less secure object storage option to maximize immediate cost savings, assuming the risk of a data breach is low. The correct answer is B. Select the more secure, compliant object storage option with enhanced auditing features, even at a higher monthly cost, to mitigate risks and ensure responsible data handling. Explanation. This scenario presents a professional challenge in balancing the immediate cost savings of a less secure, but cheaper, data storage solution against the long-term risks and potential regulatory noncompliance associated with it. The Oracle Cloud Infrastructure Developer 2020 Associate Certification implies a need to understand not just technical implementation, but also the broader implications of cloud services, including security and compliance within the context of Oracle Cloud's offerings. The core of the challenge lies in making a decision that is technically sound, economically viable, and adheres to the implicit regulatory expectations for data handling in cloud environments, even if specific regulations aren't explicitly detailed in the exam scope. The correct approach represents best professional practice because it prioritizes data security and compliance, which are foundational to responsible cloud development and deployment. By selecting a solution that meets the required security standards and offers robust auditing capabilities, the developer ensures that the application will not only function correctly, but also operate within acceptable risk parameters and potential future regulatory landscapes. This proactive stance on security and compliance, even when it incurs a slightly higher upfront cost, demonstrates a commitment to long-term system integrity and avoids the potentially catastrophic costs of a data breach or regulatory penalty. This aligns with the general principles of secure software development and responsible data stewardship expected of cloud professionals. An incorrect approach that opts for the cheapest storage without adequate security features represents a significant regulatory and ethical failure. Such a choice would likely violate implicit data protection principles, potentially leading to unauthorized access or disclosure of sensitive information. This could result in severe reputational damage, loss of customer trust, and substantial financial penalties if specific data privacy regulations were to apply. Another incorrect approach, focusing solely on the cheapest option without considering the scalability or performance implications, could lead to operational inefficiencies and increased long-term costs due to performance bottlenecks or the need for frequent re-architecting, indirectly impacting the overall cost-benefit. A third incorrect approach, over-engineering the solution with excessive security features beyond the actual requirements, would be an economic failure, leading to unnecessary expenditure without a commensurate increase in security or compliance, thus misrepresenting the cost-benefit analysis. A professional decision-making process for similar situations should involve a comprehensive risk assessment that quantifies not only the direct costs, but also the potential indirect costs of security vulnerabilities and compliance failures. This includes evaluating the sensitivity of the data being stored, the potential impact of a breach, and the likelihood of encountering regulatory scrutiny. Developers should consult with security and compliance experts, leverage Oracle Cloud's built-in security features and best practices, and ensure that any chosen solution aligns with the organization's overall security posture and risk tolerance. The decision should be documented, with clear justification for the chosen path, demonstrating due diligence. Question 13. The audit findings indicate that sensitive customer data stored in an Oracle Cloud Infrastructure Object Storage bucket is not adequately protected against unauthorized access, despite being encrypted at rest. The current configuration allows any authenticated user within the tenancy to potentially access this data. As a developer responsible for implementing security controls, what is the most effective approach to address this finding and ensure only authorized personnel can access this specific data object? Option A. Configure network security lists and firewalls to restrict access to the object storage service endpoint. Option B. Rely solely on the application-level encryption to protect the data, assuming that network security measures will prevent unauthorized access. Option C. Implement granular identity and access management (IAM) policies to define specific permissions for users or groups to access the sensitive data object. Option D. Disable all public access to the object storage bucket without implementing any specific access controls for authenticated users. The correct answer is C. Implement granular identity and access management (IAM) policies to define specific permissions for users or groups to access the sensitive data object. Explanation. Scenario analysis. This scenario presents a professional challenge stemming from a discrepancy between a developer's understanding of a service's behavior and its actual implementation, potentially leading to security vulnerabilities or compliance issues. The developer is tasked with securing sensitive data within Oracle Cloud Infrastructure (OSI). The challenge lies in ensuring that the chosen security controls align with OCI best practices and regulatory requirements, particularly concerning data residency and access management, without introducing unintended risks. The developer must balance functionality with robust security and compliance. Correct approach analysis. The correct approach involves leveraging OCI's identity and access management (IAM) policies to restrict access to the sensitive data object. This aligns with the principle of least privilege, a fundamental security best practice mandated by many regulatory frameworks. By explicitly defining which users or groups can access the object and what actions they can perform, the developer ensures that only authorized personnel can interact with the data. This granular control is crucial for maintaining data confidentiality and integrity, directly addressing the audit finding by implementing a verifiable security measure. OCI IAM policies are designed to enforce access controls at the resource level, providing a robust mechanism for compliance with data protection regulations. Incorrect approaches analysis. One incorrect approach involves relying solely on the application-level encryption without implementing OCI IAM policies. While application-level encryption protects data at rest, it does not control who can access the object in the first place. If an unauthorized user gains access to the object storage, they could potentially download and decrypt the data if they have the necessary keys, or if the application logic is flawed. This fails to meet the audit findings requirement for access control and violates the principle of defense in depth. Another incorrect approach is to assume that network security alone is sufficient. Virtual cloud networks, VCN, and security lists can restrict network access to OCI resources. They do not provide fine-grained control over individual object access within a storage bucket. An attacker who bypasses network defenses or gains access from within the authorized network could still access the sensitive data if no object-level access controls are in place. This approach neglects the specific requirement to secure the data object itself. A further incorrect approach is to disable all public access to the object storage bucket. While this is a good general security practice, it is insufficient on its own to address the audit finding. The audit specifically points to a need for controlled access for authorized users. Simply making the bucket private does not define asterisk who asterisk among authorized users can access asterisk what asterisk data, nor does it enforce specific permissions for those users. It is a necessary but not sufficient step for granular access management. Professional reasoning. Professionals facing such audit findings should adopt a systematic approach. First, thoroughly understand the nature of the audit finding and the specific OCI services involved. Second, consult OCI documentation and relevant security best practices for the services in question. Third, identify the most appropriate OCI security features that directly address the finding, prioritizing those that enforce granular access control and adhere to the principle of least privilege. Fourth, implement the chosen controls and thoroughly test them to ensure they function as intended and do not introduce new vulnerabilities. Finally, document the implemented controls and the rationale behind their selection to demonstrate compliance and facilitate future audits. Question 14. During the evaluation of a new third-party analytics service integration with Oracle Cloud Infrastructure Object Storage containing sensitive customer data, what is the most secure and compliant approach to manage data access and protection? Option A. Grant the third-party service broad read and write access to the entire customer data object storage bucket and rely on the third-party service's security. Option B. Disable auditing for data access related to this integration to simplify development and deployment. Option C. Encrypt the data using a custom encryption method before uploading it to object storage and grant the third-party service full access. Option D. Implement fine-grained IAM policies to grant the third-party service only the necessary permissions, encrypt data in transit and at rest using OCI KMS, and enable OCI audit for all data access. The correct answer is D. Implement fine-grained IAM policies to grant the third-party service only the necessary permissions, encrypt data in transit and at rest using OCI KMS, and enable OCI audit for all data access. Explanation. Scenario analysis. This scenario presents a common challenge for Oracle Cloud Infrastructure developers, ensuring secure and compliant data handling when integrating third-party services. The professional challenge lies in balancing the need for efficient data flow and integration with the imperative to protect sensitive customer information, adhering to Oracle's best practices and relevant data privacy regulations. Developers must make informed decisions about data access, encryption, and auditing without compromising functionality or security. Correct approach analysis. The correct approach involves implementing a robust security posture by leveraging Oracle Cloud Infrastructure's native security services. This includes encrypting sensitive data both in transit and at rest using OCI's Key Management Service, KMS, and object storage encryption. Furthermore, implementing fine-grained access control using Identity and Access Management, IAM, policies to grant the third-party service only the minimum necessary permissions to access specific data resources is crucial. Auditing all data access and modifications through OCI's audit service provides a verifiable trail for compliance and security monitoring. This approach aligns with OCI's security-first design principles and best practices for data protection, ensuring compliance with general data privacy principles without needing to reference specific, non-OCI-centric regulations. Incorrect approaches analysis. One incorrect approach involves granting broad read and write access to the entire customer data object storage bucket to the third-party service without any encryption. This is a significant regulatory and ethical failure because it violates the principle of least privilege, exposing sensitive data to unnecessary risk. The third-party service is compromised. All customer data within that bucket would be at risk, leading to potential data breaches and severe reputational damage. Another incorrect approach is to rely solely on the third-party service's internal security measures without implementing OCI-level encryption and access controls. This is a failure because it outsources critical security responsibilities and creates a blind spot in the overall security architecture. OCI provides robust tools for data protection, and failing to utilize them means not meeting the expected standard of care for data security. A third incorrect approach is to disable auditing for data access related to this integration to simplify development. This is a critical failure, as it removes the ability to detect and investigate suspicious activity, making it impossible to demonstrate compliance or respond effectively to a security incident. It directly contravenes the need for accountability and transparency in data handling. Professional reasoning. Professionals should approach such integrations by first identifying the sensitive data involved and the minimum access required by the third-party service. They should then consult OCI documentation and best practices for security services like IAM, KMS, and audit. A layered security approach, combining OCI's native capabilities with secure coding practices, is paramount. When in doubt, it is always better to err on the side of caution, implementing stronger security controls and then relaxing them incrementally if proven unnecessary and safe. Regular security reviews and adherence to the principle of least privilege are fundamental to maintaining a secure and compliant cloud environment. Question 15. The audit findings indicate that a developer's compute instance has been granted an IAM policy that allows it to list all object storage buckets and delete any object within those buckets, even though the developer's task only requires read access to a specific object in a single designated bucket. Which of the following actions best addresses this security vulnerability and aligns with OCI best practices? Option A. Grant the compute instance a broader policy that allows listing all buckets and deleting any object in the tenancy to ensure the developer has sufficient access for any potential future needs. Option B. Revoke the compute instance's existing IAM policy and create a new custom policy that grants read access to the specific object in the designated bucket and remove all other permissions. Option C. Assign the compute instance a policy that grants full administrative control over all OCI resources, including IAM policies, to provide maximum flexibility. Option D. Create a custom IAM policy that grants read-only access to all object storage buckets, but allows deletion of objects in any bucket to simplify management. The correct answer is B. Revoke the compute instance's existing IAM policy and create a new custom policy that grants read access to the specific object in the designated bucket and remove all other permissions. Explanation. Scenario analysis. This scenario presents a professional challenge stemming from a potential misinterpretation of Oracle Cloud Infrastructure, OSI, Identity and Access Management, IAM, policies, specifically concerning the principle of least privilege. The audit findings suggest that a developer might have been granted overly broad permissions, potentially exposing sensitive resources to unauthorized actions. The challenge lies in balancing the need for developer productivity with robust security controls, ensuring that access is granted only for the specific tasks required, and no more. This requires a deep understanding of OCI IAM constructs and their implications for security posture. Correct approach analysis. The correct approach involves a thorough review of the developer's IAM policies, specifically focusing on the permissions granted to the compute instance and the object storage bucket. This aligns with the OCI best practice of implementing the principle of least privilege. By revoking unnecessary permissions, such as the ability to list all buckets or delete objects, and restricting access to only the specific bucket and necessary operations, e.g., read/write to a particular object, the developer's access is minimized to what is strictly required for their task. This reduces the attack surface and mitigates the risk of accidental or malicious data exposure or modification, directly addressing the audit finding and adhering to security best practices within OCI. Incorrect approaches analysis. Granting the developer a broader policy that allows listing all buckets and deleting any object in the tenancy is a significant regulatory and ethical failure. This violates the principle of least privilege, exposing the entire object storage tenancy to potential compromise through the developer's compute instance. It increases the risk of data exfiltration, accidental deletion of critical data, and unauthorized access to sensitive information, which is unacceptable from a security and compliance standpoint. Assigning the developer a policy that allows full administrative control over all OCI resources, including IAM policies themselves, is an even more severe failure. This not only violates the principle of least privilege, but also creates a critical security vulnerability. The developer could potentially grant themselves even more access, revoke security controls, or impersonate other users, leading to a complete breakdown of security and governance within the OCI environment. This is a direct contravention of responsible cloud security practices. Creating a custom IAM policy that grants read-only access to all object storage buckets, but allows deletion of objects in any bucket is also problematic. While it restricts listing, it still permits destructive actions across the entire object storage service. This broad deletion capability, even with read-only access to listing, poses a significant risk of accidental or malicious data loss across the tenancy, failing to adhere to the principle of least privilege for destructive operations. Professional reasoning. Professionals should approach such situations by first understanding the specific task the developer needs to accomplish. Then, they should consult OCI IAM documentation to identify the most granular permissions required for that task. A systematic review of existing policies, comparing them against the principle of least privilege, is crucial. When an audit finding arises, the immediate action should be to investigate the scope of the identified issue and implement the minimum necessary changes to rectify the vulnerability. Continuous monitoring and periodic review of IAM policies are essential to maintain a secure and compliant OCI environment. Question 16. The monitoring system demonstrates that sensitive financial transaction data is being stored in OCI object storage without explicit encryption at rest or granular access controls configured beyond default OCI IAM policies. Which of the following approaches best addresses this compliance risk under U.S. financial regulations? Option A. Implement application-level encryption for all data before it is uploaded to object storage and rely on network security groups for access control. Option B. Store the sensitive data in plain text and assume that OCI's inherent security features are sufficient for compliance. Option C. Migrate the data to OCI block volume and encrypt the volume using a custom application-level key management system. Option D. Enable server-side encryption for the object storage bucket using OCI-managed keys and configure specific IAM policies to grant read-only access to authorized personnel only. The correct answer is D. Enable server-side encryption for the object storage bucket using OCI-managed keys and configure specific IAM policies to grant read-only access to authorized personnel only. Explanation. Scenario analysis. This scenario presents a common challenge in cloud development, ensuring that sensitive data processed and stored within Oracle Cloud Infrastructure, OCI, adheres to regulatory compliance requirements, specifically those relevant to the U.S. financial sector. The challenge lies in balancing the operational efficiency and scalability offered by cloud services with the stringent data protection and privacy mandates. Developers must understand not only the technical capabilities of OCI, but also the legal and ethical obligations surrounding data handling. The professional challenge is to implement controls that are both effective in meeting compliance standards and practical for ongoing development and operations, without compromising security or privacy. Correct approach analysis. The correct approach involves leveraging OCI's native security and compliance features, such as OCI Vault for managing encryption keys and OCI Identity and Access Management (IAM) for granular access control to protect sensitive financial data. This aligns with U.S. regulatory frameworks like the Gramm-Leach-Bliley Act, GLBA, and the Payment Card Industry Data Security Standard, PCI DSS, which mandate robust security measures for financial institutions. By encrypting data at rest and in transit using OCI-managed keys and enforcing the principle of least privilege through IAM policies, developers demonstrate a commitment to data protection and privacy. This proactive, integrated approach minimizes the risk of data breaches and unauthorized access, thereby satisfying regulatory expectations for safeguarding sensitive information. Incorrect approach is analysis. Storing sensitive financial data in plain text within OCI object storage without any encryption or access controls represents a significant regulatory and ethical failure. This directly violates GLBA and PCI DSS requirements for data protection, exposing the organization to severe penalties, reputational damage, and loss of customer trust. It demonstrates a lack of due diligence in understanding and implementing necessary security measures. Implementing custom encryption logic at the application layer without leveraging OCI's managed services, or without rigorous security auditing of the custom code, introduces unnecessary complexity and potential vulnerabilities. While the intent might be to control encryption, it bypasses OCI's built-in security features, which are designed and maintained to meet industry standards. This approach increases the risk of implementation errors, key management issues, and compliance gaps, as custom solutions are often harder to validate against regulatory requirements than established cloud-native services. Relying solely on network-level security controls, such as OCI Virtual Cloud Network, VCN security lists, to protect sensitive data stored in OCI object storage is insufficient. Network security is a crucial layer, but it does not address the protection of data itself if the storage is compromised or if access is granted inappropriately at the data level. Regulatory frameworks require data-centric security measures, including encryption and access controls at the data repository level, which network security alone does not provide. Professional reasoning. Professionals should adopt a defense-in-depth strategy, prioritizing cloud-native security features that are designed to meet regulatory compliance. This involves understanding the specific data types being handled and the applicable U.S. regulations, e.g., GLBA, PCI DSS, HIPAA if applicable. The decision-making process should involve 1. Identifying sensitive data and its regulatory classification. 2. Mapping regulatory requirements to OCI services and features. 3. Implementing encryption at rest and in transit using OCI Vault. 4. Configuring granular access controls using OCI IAM. 5. Regularly auditing security configurations and access logs. 6. Staying informed about evolving OCI security best practices and regulatory changes. This systematic approach ensures that security and compliance are integral to the development lifecycle, rather than an afterthought. Question 17. Regulatory review indicates that customer data processed by a new application must adhere to strict data residency laws requiring it to remain within the European Union. As an OCI developer, which of the following actions is the most appropriate to ensure compliance with these regulations? Option A. Deploy the application and its associated data storage services to an OCI region located within the European Union. Option B. Rely on OCI's general security measures to protect the data, assuming it will be compliant regardless of the deployment region. Option C. Deploy the application and data storage services to any OCI region and assume that data anonymization will satisfy residency requirements. Option D. Delegate the responsibility of ensuring data residency compliance solely to the operations team after the application has been deployed. Correct answer is A. Deploy the application and its associated data storage services to an OCI region located within the European Union. Explanation. Scenario analysis. This scenario presents a professional challenge related to data residency and compliance within the Oracle Cloud Infrastructure (OCI) environment. Developers must ensure that sensitive data, particularly customer information, is stored and processed in compliance with relevant regulations. The challenge lies in balancing the flexibility and cost-effectiveness of cloud services with the strict requirements of data sovereignty and privacy laws. Misinterpreting or ignoring these requirements can lead to significant legal penalties, reputational damage, and loss of customer trust. Careful judgment is required to select OCI services and configurations that align with the organization's compliance obligations. Correct approach analysis. The correct approach involves proactively identifying the specific data residency requirements applicable to the customer data being processed. This necessitates understanding the geographic locations where data is permitted to reside and be processed, as dictated by relevant regulations, e.g., GDPR for EU citizens, CCPA for California residents, or specific national data localization laws. Once identified, the developer must then configure OCI services, such as OCI Object Storage or OCI Database, to explicitly use regions that satisfy these residency mandates. This might involve selecting a specific OCI region during service creation or utilizing OCI's data residency policies to enforce compliance. This approach represents best professional practice because it directly addresses the regulatory mandate by ensuring data is physically located within approved jurisdictions, thereby preventing non-compliance and its associated risks. It demonstrates a commitment to data privacy and security, which are paramount in cloud development. Incorrect approach is analysis. An incorrect approach would be to assume that all OCI regions are equivalent for data residency purposes and to deploy services without explicit consideration of data location. This fails to acknowledge that different jurisdictions have distinct data sovereignty laws. The regulatory failure here is a direct violation of data residency requirements, potentially exposing the organization to fines and legal action. Another incorrect approach would be to rely solely on OCI's general security features without verifying specific data residency configurations. While OCI offers robust security, it does not automatically guarantee data residency compliance. The failure lies in a lack of due diligence. Security features are distinct from data location mandates. A third incorrect approach would be to delegate the responsibility of data residency compliance entirely to the operations team without developer involvement. While operations plays a role, developers are responsible for the initial design and implementation of services, including the selection of regions and configurations that meet compliance needs. This abdication of responsibility leads to a potential gap in understanding and implementing the correct controls from the outset. Professional reasoning. Professionals should adopt a compliance by design mindset. This involves integrating regulatory requirements into the development lifecycle from the earliest stages. The decision-making process should include 1. Identifying all applicable data residency and privacy regulations based on the data being handled and the target audience. 2. Consulting with legal and compliance teams to interpret these regulations in the context of OCI services. 3. Thoroughly researching OCI's regional offerings and data residency features. 4. Selecting OCI regions and configuring services to meet identified residency requirements. 5. Documenting all compliance-related decisions and configurations. 6. Regularly reviewing and updating configurations as regulations or service offerings evolve. Question 18. Process analysis reveals that a development team is building a new application on Oracle Cloud Infrastructure, OCI, that will handle sensitive customer information. The primary regulatory concern is ensuring that all customer data remains within the European Union's geographical boundaries and is protected by strong encryption. The team needs to select OCI services and configure them to meet these strict data residency and privacy mandates without compromising application performance or development velocity. Which of the following strategies best addresses these requirements? Option A. Deploy the application in an OCI region within the European Union, but bypass OCI Vault for key management, opting instead for storing encryption keys directly within the application's configuration files for easier access by developers. Option B. Deploy the application in an OCI region outside the European Union to leverage potentially lower latency for a global user base and implement custom encryption logic within the application code. Option C. Deploy the application in any OCI region and rely on application-level encryption implemented by the development team, assuming OCI's global infrastructure inherently provides sufficient data protection. Option D. Deploy the application in an OCI region located within the European Union, utilize OCI Vault for managing encryption keys, and configure OCI Identity and Access Management (IAM) policies to restrict access to the data based on the principle of least privilege. The correct answer is D. Deploy the application in an OCI region located within the European Union, utilize OCI Vault for managing encryption keys, and configure OCI Identity and Access Management (IAM) policies to restrict access to the data based on the principle of least privilege. Explanation. Scenario analysis. This scenario presents a common challenge for Oracle Cloud Infrastructure, OCI, developers, balancing the need for rapid development and feature deployment with the stringent regulatory compliance requirements inherent in many industries, particularly those dealing with sensitive data. The professional challenge lies in ensuring that the chosen OCI services and their configurations meet the specific data residency and privacy mandates without hindering the agility expected in cloud-native development. Developers must proactively understand and integrate compliance considerations into their architectural decisions from the outset, rather than treating it as an afterthought. Failure to do so can lead to significant legal repercussions, reputational damage, and costly remediation efforts. Correct approach analysis. The correct approach involves leveraging OCI's built-in compliance features and services that are designed to address regulatory mandates. Specifically, understanding and utilizing OCI's Identity and Access Management (IAM) for granular control over data access, OCI Vault for secure management of encryption keys, and OCI's regional data residency options ensures that data is stored and processed within the required geographical boundaries. Furthermore, implementing robust logging and auditing mechanisms through OCI's monitoring services allows for continuous verification of compliance. This proactive, integrated approach aligns with best practices for cloud security and regulatory adherence, demonstrating a commitment to responsible data handling and minimizing risk. Incorrect approaches analysis. One incorrect approach is to assume that OCI's default configurations are sufficient for all regulatory environments. This overlooks the fact that different regulations have varying requirements for data sovereignty, encryption standards, and access controls. Relying on defaults without explicit verification can lead to non-compliance. Another incorrect approach is to implement custom encryption solutions without leveraging OCI's managed services like OCI Vault. This not only increases development complexity and potential for error, but also bypasses OCI's built-in security and compliance certifications, potentially invalidating compliance claims. Finally, neglecting to configure detailed audit trails and access logs for sensitive data operations is a significant regulatory failure. Without these, it becomes impossible to demonstrate accountability and investigate potential breaches, which is a fundamental requirement for many data protection regulations. Professional reasoning. Professionals should adopt a compliance-by-design mindset. This involves 1. Thoroughly understanding the specific regulatory frameworks applicable to the data being handled, e.g., GDPR, CCPA, HIPAA, if applicable to the exam's implied jurisdiction. 2. Identifying OCI services and features that directly map to these requirements. 3. Integrating compliance checks and configurations into the CI/CD pipeline. 4. Regularly reviewing and updating security and compliance configurations as regulations evolve and OCI services are updated. 5. Seeking guidance from OCI's compliance documentation and, if necessary, legal or compliance experts. Question 19. Process analysis reveals that a development team is building a new application on Oracle Cloud Infrastructure, OCI, that will handle sensitive customer financial data. The organization operates under strict data residency regulations that mandate data be stored and processed only within specific geographical regions, and that access to this data be strictly controlled based on user roles and location. The team needs to ensure the application's data handling practices comply with these regulations. Which of the following approaches best ensures compliance with these OCI-specific regulatory requirements? Option A. Store the sensitive data in OCI object storage with a public access setting, managing all access restrictions solely through application code, and assuming this provides adequate protection. Option B. Encrypt the sensitive data using client-side encryption libraries before uploading it to OCI, without specifically configuring OCI's IAM or network security controls for geographical restrictions. Option C. Rely on OCI's default security configurations and implement custom, application-level access controls to manage data access, assuming these defaults are sufficient for all regulatory needs. Option D. Configure OCI Identity and Access Management, EAM, policies to restrict access to the sensitive data based on authorized geographical regions and user roles, ensuring data residency and least privilege principles are enforced at the infrastructure level. The correct answer is D. Configure OCI Identity and Access Management, EAM, policies to restrict access to the sensitive data based on authorized geographical regions and user roles, ensuring data residency and least privilege principles are enforced at the infrastructure level. Explanation. Scenario analysis. This scenario presents a common challenge for developers working with cloud services, balancing the need for rapid development and feature deployment with the imperative of regulatory compliance. The professional challenge lies in understanding and applying the specific compliance requirements of Oracle Cloud Infrastructure, OCI, as they pertain to data residency and access controls, particularly when dealing with sensitive data. Developers must make informed decisions about service configurations and data handling practices without direct oversight from a dedicated compliance officer, requiring a proactive and informed approach to security and governance. Correct approach analysis. The correct approach involves leveraging OCI's built-in security and compliance features, specifically by configuring the OCI Identity and Access Management, EAM, policies to restrict access to sensitive data based on geographical location and user roles. This aligns with the principle of least privilege and data residency requirements, ensuring that data is only accessible from authorized regions and by authorized personnel. OCI's IAM service provides granular control over resource access, allowing developers to enforce policies that meet regulatory mandates without compromising functionality. This proactive configuration demonstrates a commitment to regulatory adherence and secure development practices, which is best professional practice. Incorrect approaches analysis. One incorrect approach is to assume that OCI's default security settings are sufficient for all regulatory environments. This is a significant regulatory failure, as it neglects the specific requirements of data residency and access control mandated by various regulations. Relying on defaults without explicit configuration is a breach of due diligence and can lead to non-compliance, exposing the organization to legal and financial penalties. Another incorrect approach is to implement custom client-side encryption without considering server-side controls and OCI's native IAM capabilities. While client-side encryption adds a layer of security, it does not address the fundamental requirement of controlling data access at the infrastructure level, including geographical access restrictions. This approach fails to leverage OCI's integrated compliance features and can create complex management overhead, potentially introducing vulnerabilities if not implemented perfectly. It also bypasses the robust access control mechanisms provided by OCI, which are designed to meet regulatory standards. A third incorrect approach is to store sensitive data in a publicly accessible OCI object storage bucket with the intention of managing access through application logic. This is a critical regulatory and ethical failure. Publicly accessible storage, even with application-level access controls, fundamentally violates data residency and access control principles. It creates an unacceptable risk of unauthorized data exposure and is a direct contravention of most data protection regulations, such as those requiring data to be protected from unauthorized access and to reside within specific geographical boundaries. Professional reasoning. Professionals should adopt a risk-based approach to cloud development, prioritizing compliance from the outset. This involves understanding the specific regulatory landscape applicable to the data being handled and the target deployment regions. Before deploying any application or service, developers should consult OCI's documentation on security and compliance features, particularly IAM, network security, and data encryption services. They should then proactively configure these services to meet identified requirements. In situations where specific regulatory expertise is lacking, seeking guidance from security and compliance teams or external consultants is a crucial step in the decision-making process. The principle of security by design and compliance by design should guide all development activities. Question 20. Implementation of a new RESTful API endpoint within an Oracle Cloud Infrastructure application requires a thorough risk assessment. Which of the following approaches best ensures the security and compliance of this new endpoint? Option A. Deploy the API endpoint immediately to gather user feedback and then address any identified security issues in subsequent patches. Option B. Conduct a threat model and risk assessment during the API design phase, identifying potential vulnerabilities and implementing appropriate security controls before deployment. Option C. Rely solely on the default security configurations provided by Oracle Cloud Infrastructure Services for the new endpoint. Option D. Prioritize the performance optimization of the API endpoint during development, addressing security concerns only if they become critical issues. The correct answer is B. Conduct a threat model and risk assessment during the API design phase, identifying potential vulnerabilities and implementing appropriate security controls before deployment. Explanation. Scenario analysis. This scenario presents a common challenge in cloud development, balancing rapid feature deployment with robust security and compliance. Developers are under pressure to deliver new functionality, but overlooking risk assessment can lead to significant vulnerabilities, data breaches, and non-compliance with Oracle Cloud Infrastructure (OCI) best practices and potentially relevant data protection regulations. The challenge lies in integrating security and risk considerations seamlessly into the development lifecycle without unduly hindering agility. Correct approach analysis. The correct approach involves proactively identifying potential risks associated with the new API endpoint during the design phase. This includes considering data sensitivity, authentication mechanisms, authorization controls, and potential attack vectors. By performing a threat model and risk assessment early, developers can implement appropriate security controls, such as input validation, rate limiting, and robust logging, directly into the API design. This aligns with OCI's shared responsibility model, where developers are responsible for securing their applications and data within the cloud environment. It also adheres to general principles of secure software development, which emphasize shifting left security considerations. Incorrect approaches analysis. Implementing security controls only after deployment is a reactive and often insufficient approach. It significantly increases the risk of exploitation before vulnerabilities are discovered and patched, leading to potential data breaches and reputational damage. This fails to meet the professional standard of proactive security and can violate implicit or explicit compliance requirements for data protection. Assuming that OCI's built-in security features are sufficient without a specific assessment for the new API endpoint is a dangerous assumption. OCI provides a secure foundation. Application-level security is the developer's responsibility. Relying solely on platform security without understanding the specific risks of the application can leave critical gaps. This demonstrates a lack of due diligence and can lead to non-compliance with security best practices and potentially regulatory mandates. Focusing solely on performance optimization without considering security implications during the design phase is a direct violation of secure development principles. Performance and security are not mutually exclusive. They must be considered in tandem. Neglecting security for performance can introduce vulnerabilities that are far more costly to remediate than any performance gains achieved. This approach is ethically questionable and professionally irresponsible, as it prioritizes speed over the safety and integrity of data and systems. Professional reasoning. Professionals should adopt a risk-based approach to cloud development. This involves integrating security and compliance considerations from the initial stages of any project. A structured risk assessment process, including threat modeling and vulnerability analysis, should be a mandatory part of the design and development lifecycle. When developing new features, such as an API endpoint, developers must ask, what sensitive data does this handle? Who should have access? What are the potential ways this could be misused? By answering these questions early, developers can build security in, rather than trying to bolt it on later. This proactive stance not only mitigates risks, but also ensures adherence to OCI best practices and any applicable regulatory frameworks, fostering trust and reliability.